Exercise 10. Develop a math model for the problem. Describe the type of math problem that has resulted. Using assistance from the TI Nspire CX-CAS, solve the math problem and interpret the solution. Suppose you are in charge of promoting a product. You consider running a 30-second advertisement on TV Channel 7 for a 1-week period. Upon contacting them, you find Channel 7 has a volume discount pricing structure. For a single 30-second spot during the daytime, the cost is $350. But for each additional spot, the daytime rate decreases by $10 down to a minimum rate of $150 per spot. Moreover, this discounted rate applies to all daytime spots purchased. For example, a client purchasing 8 daytime spots will be charged 8 times the quantity 350 minus 7 times 10, equaling $2,240. As for Primetime, a single 30-second spot costs $740, but for each additional spot, the Primetime rate decreases by $20 down to a minimum rate of $440 per spot. Moreover, this discounted rate applies to all Primetime spots purchased. Your company wants to run at least 1, but not more than 20 daytime ads. Also, your company wants to run at least 1, but not more than 15 primetime ads. You have an advertising budget of $8,600. The Nielsen ratings for Channel 7 state that it has an average of 25,000 viewers during the daytime and 62,500 viewers during primetime. What is the optimal advertising policy for the week? Okay, let's see. Variables that we were going to need to model this question. Well, most obviously would probably be to let X be the number of daytime spots to purchase and let Y be the number of primetime spots to purchase. Okay, like so. Another very important quantity, the most important quantity perhaps, is the number of views. That would be the basis on which we would evaluate the effectiveness of the advertising here, just like in YouTube. So let's go ahead and we'll let V equal the number of views. Okay, and I suppose we could go ahead and formulate what that would be. The number of ad views, well, would equal, let's see, each daytime ad would pick up 25,000 viewers, and so if there are X of them, that would be 25,000 times X for daytime views. And then the prime time, a single ad would get viewed 62,500 times. If you have Y of them, you would multiply 62,500 by Y. And let's see, we are of course trying to maximize the number of views here. And let's work on the domain here. Subject to. Okay, controlling X and Y. One idea right away is, of course, physical sense. And since we're talking about each X and Y being a number of spots to purchase, these are going to have to be non-negative numbers. Call that inequalities 1. Also with the physical sense, the idea is that you have to either purchase a spot or not purchase a spot. There's no part way in this situation, so that means that X and Y must be integers. Let's see, anything else here? Yeah, we have some company demands here. It says the company wants to run at least 1, but not more than 20 daytime ads. Okay, so company demands. Alright, well, looks like that would give us 1 less than or equal to X less than or equal to 20. And along with that would be the idea that the primetime ads, we are to run at least 1, but not more than 15, corresponding to a translation of 1 less than or equal to Y less than or equal to 15. There can be a pair of inequalities we'll call number 3. Okay, what else are we concerned with? There is indeed an advertising budget. Okay, how shall we translate this? Well, if we first consider the price we're paying for those daytime ads, it says there's an initial rate of $350, but for each additional spot, the daytime rate decreases by $10 down to a minimum rate of $150 per spot. Okay, so we have this initial 350, but then we get to deduct from it. Now it's for each additional spot, so we can't subtract x times 10. Additional spot means x minus 1. Those are the additionals, and then times 10. Now this is the rate, and then if you purchase x of them, you then have to multiply this rate times the number of ads. Okay, now let's add to that the cost of the primetime ads. It's a similar idea. The initial cost is $740, but then you get to deduct each additional spot, so not y but rather y minus 1. That's the number of additional spots, and times 20. Each additional spot gives you that much of a deduction, and this is the rate for the prime times, and then it's times y. And this quantity must be less than or equal to 8,600. Okay, we could call this 4. Okay, and maybe in this case, since there is the keyboarding to consider, we might actually do well to simplify this a little bit, this inequality. This 350, we're minusing what would become 10x, and then subtract a negative, add 10. Alright, so that would actually give us a effective rate of 360, and then minus 10x times x, and then plus, here we can multiply the 20 by the y minus 1, and that makes us then a negative 20y plus 20. That would give a net effect of then 760 minus 20y times y, and that's less than or equal to 8,600. Okay, so here's 4a. So let's see, what do we think about this math model? I think that's all of the restrictions for the domain. Here's our function that we're trying to maximize. It's linear. Okay, let's look at these restrictions on the domain. We have here, okay, linear constraint, x and y are integers. Okay, this is going to put us into the integer programming realm, and then these other restrictions, okay, linear, and here's a non-linear constraint. Okay, so we are surely out of the realm of linear programming as even a possibility to attempt this question. Alright, so it looks like we have the claim that this math model is an integer programming problem. Okay, so that we've written it here. Since that's the case, it looks like we're going to be needing to write a computer program, to get this figured out. Before we actually go to that stage, though, it might be a nice idea to maybe draw a sketch of the domain of this function, at least. That might kind of be helpful as a check and has a help of getting us motivated on even where to begin our computer program. Okay, and there's actually still another aspect of this advertising budget to consider. So maybe we should put an asterisk right here, and so then we go down here, and the concern is this: we translated the information to come up with this quantity, or I guess we've simplified it to this quantity in the parentheses here as being the rate at which the primetime ads are being paid. Now, there's another question though, and that's it. Is this always the case? Because remember, when the cost of the daytime ads was formulated, or was stated, it said they're $3.50, but for each additional spot, the daytime rate decreases by $10 down to a minimum rate of $150 per spot. Now, have we overshot the minimum here in our problem? And then we'd have to have another formulation for certain x's if that's the case. Okay, so the maximum sensible x here, because of the company demands, is 20. Okay, so at x equal to 20, what do we have for 360 minus 10x? 360 minus 10 times 20, that would be 200 there. 360 minus 200 is 160. Okay, so we have not yet hit that minimum rate of 150. Alright, so it's greater than 150. Alright, and now let's also consider the situation for the rate of the primetime ads. We formulated that rate as being 760 minus 20y, but the specifications were that this is valid down to a minimum rate of $440 per spot. Okay, so what's the largest consideration for y here? It is 15, right? Okay, so the largest considered y equals 15. At y equals 15, what happens then? We would have 760 minus 20 times 15. Okay, so what's this? This is 300. 760 minus 300 is 460. 460 is, okay, above the minimum there. Okay, so what's all this mean? This means that our rates apply throughout this entire problem. Okay, so the formulated daytime rate and primetime rate apply throughout the entire problem. Okay, so here at the Nspire, let's start off with opening up a new document, and let's add a graph application. Okay, getting started, looking over some of these inequalities: x greater than or equal to 0, y greater than or equal to 0, and then the company demands number 3 there, x lying between or equal to 1 and 20, y between or equal to 1 and 15. I think I'll, just to get started, I'm going to go and change the window on this, and maybe a little bit of room so that we keep the x and y axes and have a kind of like a margin of space as well. So perhaps something like -4 for x min, maybe 24 for x max, and scaling 1 apiece, and the y min, perhaps a -3, and the y max perhaps an 18, and scaling, let's go 1 apiece there. Alright, so we start here. Inequalities 1 by simply doing inequalities number 3. So let's start with the y part there, y between 1 and 15. Alright, so we need two horizontal boundary lines here. One f of x equal to 1. Okay, and another f2 of x equal to 15. Okay, and I think I'm going to come here and make this graph the same color as the other one, red. Okay, and now how about the x equal to 1 and the x equal to 20? Well, those are vertical lines. Alright, so a nice way to do that would be to go to the menu here and go to construction and perpendicular line. We want it to be perpendicular to the x-axis, so click on there. Now I have a very specific equation in mind here, the x equal to 1, so I'm going to go ahead and now start to put in a points coordinate, and that means a parenthesis. Now it's waiting for an x coordinate. Okay, 1, and hit enter, and a y coordinate really could be anything, but I'll just keep it on the x-axis and put it as 0, and then enter. Alright, so now we see this vertical line appearing, and well, let's see, while we're at it, maybe we could go ahead and get our second vertical line started here. So there's the axis. Now this time, let's start putting a point in. That'll be an x coordinate of 20. We could put a y coordinate of 0. Okay, now let's put away the perpendicular tool, and let's fix up these lines a little bit. For one thing, longer, pull it out here. Okay, another thing, I think I sort of like the red colors of these basic lines. I think looks kind of nice, so I'll go to the line color here, choose a red, and how about its equation? We could go here and pick coordinates and equations and get the equation for this vertical line. Let me just move it outside over to here. Okay, and similarly with this right hand line, the same, I guess, 3 steps here. First, extend it. Let's make it red. And then we could give it its equation. Okay, looks pretty good there. Let's move this label here, if we can, out of the actual domain itself. Okay, that looks alright. Now, what remains? Inequality 4a here to work with. Its boundary line would be the equality case. This equality case would actually be a bit of work to get the graph for. If we were going to try to use functions, we'd have to solve for y. Would be a bunch of algebraic steps, kind of complicated. We can avoid that by graphing this as an implicitly defined function. We need to first set things equal to 0. Okay, you can do it mentally. Just subtract 8600 from both sides, and then use the zeros feature on the Nspire here, like so. Bring up an entry line, and we'll request zeros. So zeros. See how it changes the font from italics to regular, so we know we have an official function in place here. And in here we can put in as the argument this equality set equal to 0. So for us that means, okay, so far we have this much keyboarded in. Now we need to do the subtraction of the 8600. Alright, then would come a comma and then a y, and then the other parenthesis, and enter. Okay, there we have another boundary line. And which side of this gets the shading? Well, you could sort of just go with the sensibility idea that this is supposedly a boundary line for budgets. So obviously we have to be keeping fewer ads being run, which puts us to this side here of the boundary line. That's one way to think of it. Another way to proceed purely mathematically would be to substitute a point and see what occurs. For instance, you might substitute 0, 0 into the inequality there and find yourself having a 0 less than or equal to 8600, which is true, telling you should be shading 0, 0 side of this boundary line. Okay, so either way we think of it, we know which side of the purple line gets the shading. Now, again, we have these 4 red lines here, which we are interior to this rectangle, and now we are below this purple line as well. And then really, there's kind of more that we could add on to this, and that's that x and y are supposed to be integers. Okay, we can put this feature on the graph. We've already set the x and y scaling at 1 unit apiece, so that means our grid will give us integer coordinates all having 1 unit change between any x or any y coordinate. So let's right click right here and put the hide show the grid. Okay, now although there's no easy way to actually shade what we're looking for, we have to proceed a little bit mentally. We are interior to this line, this line, this line, this line, this line, and we must be or on any of those lines, and we are one of the points here which have all integer coordinates. Okay, so now that we have this domain here, we can now think a little bit more about how we're going to solve this integer programming problem with a computer program. The basic strategy is going to be to evaluate the number of views function at each point in the domain and select the largest number. Okay, now that being the case, we need to generate the domain for the computer program. How can we do that? Well, an initial starting point we can see would be to generate a rectangular array of integer coordinate points where x ranges from 1 to 20 and y ranges from 1 to 15. Then after we have that rectangular array of points, we then could create a filter so that only the points below the purple line proceed on to the view function evaluation. Okay, well, let's go design our computer program now. Okay, so here we are, getting ready to design a program, and I think our program is going to consist of two modules. The first module we'll try to figure out what is the maximum number of views, and we'll also have a point at which the maximum number of views occurs. Then we can have a second module which we'll use to figure out if there are some other points at which the maximum number of views is achieved. Okay, and to help communicate our program, one nice thing to do in a program like this is to put it into the program itself, a little explanation, and you can do that while using the coding for like a copyright symbol, and then this gives you a chance to just write in some commentary text on what we plan to do here. So we'll do that now. Okay, so maybe something like this. This first module will determine the maximum number of views as well as a point xy that yields this maximum. Alright, now let's think back to what we were thinking about when we were looking at that graph of the domain, and we said we could first generate a rectangular array of integer coordinate points. Okay, we'll write that in our description here. Okay, so in words we're going to try to generate a rectangular array of integer coordinate points, x going from 1 to 20 and y going 1 to 15. Okay, what kind of computer code will work for us here? We can use counter loops. So that looks like this. For the first loop, oh wait, let me leave some space here because I'm going to want to put probably some more starting ideas up here. Let's start this counter loop maybe down here. So it goes 4, and the syntax is the variable, I suppose we choose an x, the lowest number 1, the highest number 20. Okay, then you need to put the capping end statement for this 4, and we could put that perhaps here, and 4. Alright, so in here we'd have x being 1, 2, 3, 4, 5, and so on. Now, interior to this, we put a counter loop for the y's, so then we get xy points generated, and same syntax for y, 1, 15. Okay, and this for y 1 to 15 needs its end statement, so that goes in here. Alright, so now this has created the rectangular array of xy's, x going from 1 to 20, y going from 1 to 15, all integer coordinates. Okay, after we had generated that rectangular array, our next step we thought would be to then create a filter that only passes the points that are in the domain of the function. Okay, so we're going to create a filter that only passes points in the domain. Before we get to that, one other item going back to this rectangular array. In the coding, we chose x and y, which is nice because for counter loops you want very simple letters for your variables, and these letters even match our formulation of the function, making them extra clear to us for our interpretation processes later on. However, it's not a good idea to use x and y as variables with the Nspire. It can cause you troubles in other applications. So, to make sure that this x and y just serve as variables within this program, we also would come up here and define these to be local variables for this program. So that means local x, y. Okay, there. Onto our filter that's only going to allow points in the domain to go further into the analysis. For that, we can use a conditional statement, and we could then say here, if, now here's where we need to get the points that lie below that inequality there. So as a shorthand, we could say if and refer to our formulation, which we'll of course have to write out explicitly when we get to the Nspire. Then, alright, now only the points in the domain proceed on into this portion of our program now. We need to include the end statement that goes with this conditional, so here we could have an end if there. Alright, so now we have only points in the domain proceeding forward. What to do with them? Well, now that we have our domain points, it's time to evaluate the viewing function at each point in the domain and keep track of the largest value. Keep updating it as a progressively larger and larger value is found. Okay, so we're planning to evaluate the number of views at each point in the domain, and we'll keep updating the largest value as we encounter a larger value. How can we do that? Alright, so again, proceeding into here, we have all the domain XYs. Okay, we could do an evaluation and see if it's larger than the current maximum value. So here another conditional if, and let's see, we're going to need to bring in the number of views function. Maybe here we could call it I guess just maybe we use views. Okay, let's use views, a little more descriptive. So if views of x, y is greater than, we will be storing the maximum number of views in a location, let's call it a vmax. Then, okay, now if this happens to be the case, we will start updating the maximum number of views variable. So for instance, we'd have vmax assigned to be views of x, y. We can keep track of the corresponding x and y coordinates at which this maximum occurs. We can call them x max and y max, so we could update them. X max, assign that to be x, and y max, assign that to be the y. Alright, now let's see, another related items here once we say this. Alright, what about the views of xy function? It's not known to the calculator at this point here. We'll need to bring that in. That should be brought in early on. It's a definition, so here we can use the define command, define, and we'll say views of x, y equal to, just go back to our formulation. It was 25,000x plus 62,500y. Okay, and another little item here. And the first time this program comes through and it starts to make this comparison about the number of views at xy being greater than vmax, it's stymied because it does not have any vmax stored here to begin with. So we need to get that initialized. Alright, so also up here we could have vmax. We can initially assign it to be, I usually think of something nonsensical, -1 to get started. That way I help detect an error in the program if I do something like this. Okay, what else here? Now at xmax, we do not have to give that an initial value here because this statement defines it by itself, and since x is already known because of the counter loop, we're all set. Same is true for the ymax. It gets defined properly because there already is a y that is generated by the counter loop part of this. Okay, so now we've made this comparison. We then update into the vmax, the latest large number of views, and the corresponding x and y. Okay, this will also need its corresponding end statement, so then we perhaps about here could record the end if belonging to that. Okay, now I suppose we're ready to talk about finally emerging from all these counter loops, all this evaluation stuff, and at this point it's probably a good time to express results. Alright, so we have in mind it's now time to state conclusions, and for that an output statement is a display statement. And what should this say? The first thing we'd like to talk about is, of course, the maximum number of views. Okay, so we want to put first some text here, so for that you need quotation marks, and let's start that. Okay, so we will display the maximum number of views is, and then a space, that'll be the end of our text. Okay, comma. Now here's where we would record the Vmax. And, okay, it's a sentence, so I suppose we'll put a comma, and the only little bit of text we need is a period to end the sentence. Okay, now in another sentence we would probably like to talk about the corresponding XY and interpret that. So another display statement with some text. In case we might have a sentence say, this can be achieved by purchasing, now end the text there with those quotations, a comma, the next variable will be Xmax, and then a comma, and then the sentence can continue, so quotation marks. And what about this? Okay, so this can be achieved by purchasing Xmax daytime spots, and the quotations and text here, a comma, and here's where Ymax would be recorded. Another comma, and more text to finish the sentence here, primetime spots, and a period, end of text there. You know, it might actually be kind of nice to also display a little extra something here. Okay, it's true, we're out for the absolute maximum number of views. We certainly need to know how many daytime spots, how many primetime spots to purchase. Another little thing, and this is where you start, think about your client here instead of only answering the immediate math question, and that's that it might be of some interest to know just how much this policy is costing. Sure, we have a budget, but maybe we didn't use all of it in getting this optimal number of views. Who knows? So let's also record that too. That might be kind of interesting. So here, another sentence. Okay, so we have in mind another sentence to say, the cost of this purchase is, and the units of measure will be dollars, so there's a dollar symbol. But now, what do we put here? Okay, actually we don't have anything immediately for this. We might as well just go ahead and create a cost function and have it ready for use in this sentence here. So in other words, this is the end of the text, a comma, and now we will grab a hold of the we'll call it the cost function and evaluate it at X max Y max. Alright, now of course we now need to then record another definition, which brings us back up into the beginning part of this question, where this is a nice place to put this kind of thing. And so we have another define, and we could have cost of X, Y equal to, okay, we go back to our formulation where we're considering cost and take the that quantity and record it here. Okay, like so. Just using our previous math formulation, the left-hand side of that budget inequality is indeed the cost of purchasing the ads. Okay. And otherwise, we'll have the end function statement appear at the very end of this, and we are ready to go to the Nspire now and keyboard in this coding. Okay, at the Nspire, we probably should add a page. And for the program editor, you can either add a calculator and go from there, but that will give you a split page, and I like to have a page just totally dedicated to the program itself. So what I do is I do this second option, which is to click on Document again, Insert, Program Editor, New Program. Okay, let's give it a name. We could call this Exercise 10. And there it defines Exercise 10 as a program, and it's awaiting our first command right here. Alright, Well, let's see. Looking at our formulation, the first thing is a description of the first module with a comment statement. Okay, to do that, Menu, Actions, and number 8, Insert Comment. There's that copyright symbol. Now just keyboard in. Okay, like that there. And now we can maybe skip a space since that's a description of the module, and now a part of the kind of definitions phase of this program. First, we were going to call x and y local variables. You can actually keyboard in, LOCAL, it works that way, or you can go to the menu. You can go to the define variables and see number 1 there is local, and then we could put in our x, y. Okay, next we have a define. You can keyboard in the word DEFINE, or you can also go to the menu and pick number 2, which is define there for us, and keyboard in what we have said as far as the views function. Okay, like so there, and hit enter. Next line, time to provide the initial value for Vmax. This will be a sign to be equal to, like so, or you can keyboard in a colon and an equality sign next to each other, and we decide it would be a -1. Okay, enter. Now it's time to define our cost function. Okay, very similar to how we worked with the views. We can go to the menu if we want, define variables, define, and now let's keyboard in that cost function that we've formulated. Okay, there's that cost function just as we formulated it. So enter, and I think I'm going to leave an extra space here because this is now sort of done with the definitions phase of the program. It's time for the core commands, and so our first one here is the counter loop here. So for that, it's menu, we want control, and we want the for and for. Alright, you notice we get the for with the commas already there. Alright, now let's just follow what we have written before. We had our variable, I'm going to forward, and then 1, and then I'm going to forward to get past that comma, and a 20. Alright, by the way, we could look down further down the program and just to confirm that the Nspire has indeed provided the end for statement already for us there. Okay, so now let's enter, and time to bring in another counter loop. So back to the menu, and back to control, and back to the for and for, and this time it's y, forward arrow, starting with 1, forward arrow, going up to as much as 15. Okay, and enter. Alright, here comes our conditional. Now, since this is interior to all of our loops, I'd like to indent a little bit here, so I'll put like 4 or 5 spaces or so. And now I can go to the menu and go to control, and an if, then, and if structure, number 2. Okay, now referring to our inequality of our formulation. You know, now that we have gone to the trouble of defining this cost function, we can even simplify our writing of that inequality. It actually could also be thought of as saying that the cost of xy is less than or equal to the 8600. So let's take that shortcut at this point. Okay, and proceeding out here to after the then, enter, and now we have another conditional. I'm going to indent a little bit here again since we're into this aspect, and it's an if then and if structure again, so we could go to the menu and go to control and if then and if, and this time the if portion is to take advantage of or to utilize our views. We want to know if the views at xy is greater than the current maximum number of views known. Okay, then, and here's where we start updating all of the maximum variables, so as we've written here. Okay, and since here's where the end if is to be recorded, I think I'll just delete this space, and I think I would like to also delete this space here and delete this space here. Okay, and also delete the space between the N4s. Okay, now following the final N4 here, this is where we get into the displaying part of the program, and I think I'll also leave a space here since this is sort of a different aspect of this first module, so a little space to separate matters here. And it's time to record our display commands with their text and variables. So in each case, the display command, by the way, is menu, input, output, display, or alternatively you can actually keyboard in DISP. It accomplishes the same thing. Let's put a set of quotes here, and you notice when you do that you get the initial quotation mark and the final quotation mark with a text box basically awaiting for you to keyboard away. Okay, we have keyboarded all of those display commands in with all their text and variables. At this point it's time to, well, have the Nspire check syntax and store this program. For that, Control B. Control B. Good news. It says there in the status line that exercise 10 is stored successfully. Okay, well now let's go ahead and actually try this program out and see if at least this first module seems to be providing some sensible results. So for that we can add a page. Let's add the calculator application. Alright, let's go to the variables menu. Exercise 10, see, it's a program variable right now. We go ahead and put it there and enter. Okay, interesting. We got a looks like a sensible result of sorts here. So the maximum number of views is 1.0625 million, and this can be achieved by purchasing 5 daytime spots and 15 primetime spots. The cost of this purchase is $8,450. Okay. Well, let's give this kind of a check over. The first thing we might do is take this claimed point, which would be 5 for X, 15 for Y. Let's see if it looks to be in our domain that we sketched earlier. So for that we could go back to the page 1. We can give ourselves a visual by doing a menu, points and lines, point, and let's go ahead and take the coordinates. We have 5, enter, 15, enter. There it is there. Okay, I'll put away the point tool, and you know it is very much in the domain here. We can also, by the way, while it's here, put its coordinates right there and maybe move it right there. Alright, so, well, at least this much is making sense. It is, this maximum value is coming from a point in the domain. We wanted to see that. Something else we can do here to sort of check out all the numbers and these sort of things. Let's challenge this 515 with, how about this? Let's go over here to this point 615. Now, what should happen here? At the point 615, which means increase the daytime spots by 1, we should find that we get more, 25,000 more views, but we should find that this is an over budget situation that would disqualify it. Okay, and let's kind of go back and test out this idea. So we could go back to the page in which we had the program record a conclusion here, And now, since we have in mind writing a fair amount of text, it might be a good idea to, I'm going to copy this text and open up another page, but this time a notes application to start writing text type things here. So first of all, paste that conclusion in there at first, and now we can go ahead and talk about checking. Okay, so we've written here check. Firstly, the point 515 graphically appears to be in the domain. Alright, that was good to see. Secondly, we're going to consider this point 615. The corresponding numbers of views is, now to crunch the numbers here, I'm going to not use anything that's been formulated or keyboarded in the program. I'm going to look back at the original formulation of this question, and since this is a calculation item in a notes page, let's open a math box. For that, it's a matter of doing a Control M, opens the math box, and let's get these number of views by looking at the original problem statement. We have here these 6 daytime ads, so that would be 6 times. Looking at the information, it says 25,000 viewers per daytime, and then we'll add to that now 15. That's 15 primetime spots. 15 times, looking back at the original formulation of the question, it says 62,500 viewers, and enter. Okay, let me touch up this math box a little bit here. Attributes, let's make that an equality there. Okay, now this number should be, well, 25,000 greater than the optimal claim. Let's go back and just kind of look at that number there, 1,062,500, and increasing that by 25,000 would indeed bring us to this number here. Okay, so this is consistent. Let's write that. So this is consistent with the expectation that this be 25,000 more than the claimed optimal. As for the cost of this purchase, okay, time for another math box. So let's go with Control M, and let's work this out fundamentally. We're having 6 daytime ads. Now, what will we times that by? Looking at the original formulation, it said here a 30-second daytime spot is $350 for one, but for each additional spot the rate decreases by $10. Okay, so right now we have 5 additional spots beyond 1. That corresponds to 6, and that means that we would reduce the $350 price by $50, so that would be a $300. And now let's go ahead and think about this primetime cost. We have 15 primetime ads in this scenario, times how much would these cost? Going back to the fundamental formulation, a single 30-second primetime spot is $740. The price decreases, the rate decreases by $20 per each additional. Okay, so now we have 14 additionals. At 14 by 20, that would be 280. So now we subtract 280 from 740. That would give us, let's see, 76540 and down to 460. Okay, so 460 there, and enter. And okay, good. This is what we want to see. We wanted to see it be over budget, but not too much more than, or rather not too much over budget, which makes sense. The budget was for $8,600, and this is at $8,700, and that is consistent with what we are expecting here. Okay, so this first module has checked out pretty well. It looks like indeed the maximum number of views is as specified there, and we have a purchase that will yield that maximum. Now what we want to do next is consider if there are some other purchases that may also yield this maximum number of views as well. Okay, for that we need to create a second module of program. Okay, so now we return to our designing of the program Scratch worksheet, and we can start off by perhaps using a comment to describe what the second module is going to be. So maybe directly here to the coding side of this, we know the copyright symbol is the command for a comment, and let's go ahead and describe what we're going to do here. Okay, so there's our comment to describe this. This second module seeks additional points XY, which also yield the maximum number of views. Okay, so basically we're going to process through the domain again and make a note of points which also yield the maximum profit. Our first step here will be to basically create the domain again. So firstly we regenerate the rectangular array of points XY, where X goes from 1 to 20 and Y goes from 1 to 15. Okay, so that describes what we're going to do. What's the source code for this? Begin, as before, we'll use those counter loops to create this. So that would mean, let's say starting here, for the variable, the starting number, the final number. And then you have to include the corresponding end statement for this, so perhaps here. Okay, and then we have to also generate the Y sequence, so another one, variable Y, 1, 15, the corresponding end statement down there. Okay, now that we've done that, what happens next? Well, now we could create a filter which passes on points that are in the domain and satisfy the number of views equaling the maximum number, and they are unique. Okay, so writing that down. Okay, so there's our description. Create a filter that passes on points which are in the domain and satisfy the number of views equaling the maximum number of views, and they're unique. So we don't want to have the same point that we already know about from our first module. They should be new, unique. Okay, for creating a filter, a conditional statement works pretty well here. So how could this look? We could go ahead and say if. Alright, now to get this into the domain, the remaining restriction has to be that constraint which concerned the cost, and so we could have here cost of XY less than or equal to 8,600, and we're looking for views of XY equaling the maximum, and want this to be a unique point, so let's make sure that it's different from X max, Y max in at least one coordinate, and we could do that by a statement such as a requirement such as X not equal to X max, or Y not equal to Y max. Then, if it passes through this filter, what should happen then? Well, we should immediately state results. So, for the coding, it's time to go ahead and record a display statement then. And we could have, so we could display the maximum number of views can also be achieved by purchasing X daytime spots and Y primetime spots. Okay, and then while we're displaying that, it might also be interesting to also record a display of the cost of this purchase is in the dollar symbol, and then have cost of XY function record its value there. It might be interesting to see that as well, and then another period. Okay, almost done. One other thing that might be nice to do, and that is that if this second module goes through and finds there are no other ways to obtain the maximum number of views, we might state that as well. even though we could just let it say nothing and have it indirectly claim that as a part of our conclusion, it's better to show that we really did think about this and state clearly that there are no other ways if that's the case. So here, so we're basically saying if no other ways to achieve the maximum number of views, state this. Alright, how can we do that? Well, we first sort of need to be able to keep track of whether or not anything's been discovered in this loop here. Oh, by the way, this if needs its corresponding end statement. Okay. Anyway, back to this. We need to somehow keep a record of finding any additional points that yield the maximum. So we could bring in a counter to help keep track of this for us, and we can call it a alternative counter, or alt count for short, and here we can initialize it up here. So we could say alt count assigned to equals 0 at first, and then if we come all the way into the interior of this conditional, pass the filter, find something, we may then, or we should then also increase alt count by 1 notch as the last part of this conditional. So here we could say alt count assigned to be alt count plus 1. Okay, now we have a device that's keeping record of whether or not we found anything, and then we can, upon exiting all of the counter loops, finally look for just the situation, and for that a very simple conditional. We could go with an if alt count equals 0. Okay, in this simple structure here, just an if statement alone, if this condition is met, meaning we found nothing else, it will execute this next command. So we could then have a display and record that there are no other ways to achieve this maximum value. Like that there. Display, all text, there are no other ways to achieve the maximum views. And then that would be the end of the program. And so let's go ahead and take the second module and put it into the Nspire. Okay, back at the Nspire, we have our notes page here where we're recording conclusions. I suppose we could go a little further now and say something such as, okay, so in our notes page here, next we examine for other ad spot purchases which also yield the maximum number of views. The result, okay, now we need to get our program with the second module. Let's go back to, here it is, page 2 is our program source code, and going down to the end of the first module. Okay, we'll need to get out to the end of this last line there. Okay, then I enter, and I think I'll put a second enter, even a third one, because this is a whole second module. I like it very separate from the first module for clarity. And the first thing we said was we plan to put a comment statement describing what this is going to do. Okay, how do we do that? That's a matter of going menu, actions, and insert comment. There's that copyright symbol and a space, and just proceed to keyboard in our comment we have in mind here. Okay, so as we said, this second module seeks additional points XY, which also yield the maximum number of views. And our first line of real code here is initializing the alternative counter to 0. So assigned to be, control assigned to be 0. And now we can start our counter loops here. Can go to menu, control, and 4 and 4. And as we have here, X beyond the comma, 1 beyond the comma, 20. Alright, and the second counter loop that goes with it, once again we can go to the menu, control, 4 and 4, and this time it's the Y, forward arrow past that comma, 1, forward arrow past that comma, 15. Just to make sure things are going as we expect, let's go down here and look to see our end 4 statements have been put in. Good to see that. Okay, this next line here, maybe some indentation. It's our conditional statement here. This is an if-then, end-if structure, so we could go to the menu, control, if-then, end-if, there, number 2, and we're ready to put in what we have described there in our scratch work. We're going to simplify this a little bit by saying if the cost at XY is less than 8,600, we've defined a cost function, so this will be perfectly good. Okay, we need and. Now we want to have views at XY equaling Vmax. And now that condition where we're requiring this to be a unique point, so we want to make sure that X is not equal to Xmax. Now if we go forward, we should see the then. Okay, good. And let's go down and keep indenting here to keep this conditional organized. And now come the display commands that we have described here. You can either write display, keyboarding in the letters DISP, or you can go to the menu and go to input output and select it like that. Either way. And we need to put in our quotation, which gives us both the beginning and end quotation, and the text box awaits us, so we just kind of keyboard away here. Okay, about like so. The first display and the second display is the cost of this purchases in recording the value of the cost function. Alright, hitting enter. Also part of the conditional if here is to increase that alternate counter by 1 unit. Okay, let's see, we have our end if there. There's an unnecessary space between these end statements here. As we exit the counter loops, here's where we're also going to see if there are no additional ways to achieve the maximum number of views. So here's where we could go ahead and put in our just regular simple if. You can just keyboard it in if, and then okay, and then that would be the end of the program there. Well, let's see what happens. It's time for us to have the syntax checked and this program stored. That's a Control B. Great. The status bar says exercise 10 stored successfully. Well, let's go ahead and run the program. For that, we go to our calculator page here, because the notes page will just tell you that the program is done, whereas we want to see all of the output of this program, so that's why I choose to put it on this calculator page. Okay, here we go. It's a matter of going to the variables and exercise 10 and enter. Oh, there is indeed another way to achieve this. Okay, so the program gave the first module result, case citing the maximum number, and we're aware of the purchase of 5 daytime and 15 primetime spots. But now it came along and also found that the maximum number of views can also be achieved by purchasing 20 daytime spots and 9 primetime spots. The cost of this purchase is $8,420. Actually, a little bonus there. We weren't really looking for this in our problem here, but there's actually a slight advantage to this additional method, and that is it actually costs a little cheaper. We didn't use as much of the advertising budget by doing this. Saved $30 quick by doing this, if they choose this. Okay, so let's see here. Let's take this to the notes page and give it at least one check over. We're pretty confident already with the profits, with the number of views function working properly and the cost function working properly because of our check of the first module. But we would like to make sure this point is, for instance, in the domain and such. Okay, so first of all, start getting this copied and onto the notes page. Alright, I guess I'm going to do this in 2 steps. Copy, notes page. Alright, the result. Get a new line here and paste. Okay, now I have up to the 20 daytime spots and 9 primetime spots. I wasn't able to get this all copied, so I need one more. Okay, and need a period at the end of that sentence. Okay, now let's see. Let's give this at least a little bit of a check over. As for a check, okay, let's see if this is in the domain here. 20 daytime spots, 9 primetime spots. We could just kind of go back to the first page, and we could do a point. Alright, and we have in mind the point 29. 20, enter, 9, enter. Where's that? Escape the point tool. Visually, looks like it's indeed in our domain. It's below that constraint there. And so it does seem to be working out for us. Okay, we can make a note of that. Okay, so this point indeed appears to be in the domain based on the graph of page 1. The views function and cost function have already have been checked following the first module. Last thing we might want to do is come back here to our major conclusion that had both modules and make this sort of jump off the page, which means bold font would be nice here. So we can do that, selecting all of this final conclusion statement, go to the format, going with bold, and have something like that there. Finally, let's take a look at the computer view of all this to more clearly see the entire pages of our work. Okay, so here we are with our full source code of exercise 10, and most of what we see here is the first module, and then we went on and create a second module which appears further down here like so. Alright, brings us to here where we wrote all of our major conclusions, with the most significant portions being in the boldface font there, with the additional bonus that we've even discovered that although there are 2 ways to achieve the maximum number of views, there's a slight difference in their cost, which wasn't really part of the question, but again, if you're a consultant for somebody, they're very happy to find the cheapest way when they weren't expecting you to do so. Okay, very good. That's it.